Okay, so now we're on the third lesson of our geometry unit. We're going to talk about the angles of polygons and of triangles. Some of this is going to be review and some of it will be new. So the first thing is something you should be familiar with, the triangle sum theorem. And that's the theorem that says if you add up all of the angles in a triangle, the sum of the angles is 180. So it can be a right triangle, it can be obtuse, it can be acute, whatever it is. If you add up all of those interior angles, they have a sum of 180. Then in book 1, it teaches you the exterior angle theorem. And I can't remember if you all actually covered this one last year or not, but it was in that textbook. An exterior angle is anytime you take a shape. So say I have this right triangle. If I extend one of the sides, that outside angle is called an exterior angle. And it doesn't matter if I extend this way to get this angle, or if I had extended this side and gotten this angle. What do you notice about those two angles?
They're the same.
They're the same. So it doesn't matter which of the two sides that are coming together that you extend, but you would either extend one or the other. You would never extend both. So this angle 4 out here is the exterior angle for angle 3. And what the exterior angle theorem says is that this outside angle is equal to this angle and this angle added together. So we're going to use that theorem to do some different things. We'll skip over these two. We'll come back to them in a minute. So in your packet, these are the first two examples. We have the measure of angle C is 76 degrees and the measure of angle B is 68 degrees. Yes? Question?
For the exterior angles theorem, is it important which line you extend?
It doesn't, as long as the other two angles are the angles that aren't touching it.
Okay, thank you.
So for this one, we've extended line, we've extended this line and created this exterior angle out here, and it says that's the one that we're wanting. Now we do need to be able to name these angles. So sometimes you can name an angle with one letter. For example, this angle over here is just angle C. This angle out here is just angle B. But because A has several different angles coming off of it, we have to use 3 letters instead of just one to name it, so we know whether or not we're talking about the acute angle or the obtuse angle or the straight angle. So if we're talking about this angle here, we can either call it angle BAG, or we can call it angle GAB. What's the same about those two?
The A is in the middle.
The A is in the middle. So the vertex of the angle always has to go in the middle when you're naming an angle, but it doesn't matter which end that you put those two on. If we were talking about the inside angle, we would call it CAB or BAC. Okay. I'm going to call mine angle BAG. And it says find the measure of each angle indicated, and so we're looking for that one since that's the one where the question mark is. And we know that that is equal to the sum of these other two angles. So 76 plus 68, and angle BAG is 144 degrees. On number 2, we're looking for this angle here, so we're looking for the measure of angle DRQ or QRD. The little M in the front of the angle stands for measure, so we know that we're looking for how many degrees that angle is. And then we would use the two angles. We wouldn't use this angle here that's inside. We would have to use the opposite two, so 70 and 50. 70 plus 50 is 120 degrees. Those are pretty straightforward when they're just numbers. What do you notice is different about the next two?
They have letters.
Yes.
Very.
They have variables, and now all of a sudden we have expressions. We have binomials instead of just numbers. But we can still set up whatever we want. They said find the measure of angle R. So you might highlight angle R so you know when we're finding X, then we can plug it back in. On your assignment, know that sometimes it just says solve for X. And if it just says solve for X, that's all you do. But on this one, it says find the measure of angle R. So we're going to solve for X, and then we'll plug it back in. So we know angle R plus angle S equals this outside angle, JQR. So we're going to set up an equation. 5x plus 2 plus 87 is equal to our other angle out here, 14x plus 8. And at this point, you're going to do whatever you can to simplify it. Combine any like terms if you can. We can add the 2 and the 87. And then since we have variables on both sides, right, we need to get the variables all to the same side and the numbers to the other side. So I would start by subtracting the 5x. 89 equals 9x plus 8. Subtract the 8. We get 81 is equal to 9x. So x is equal to 9. So we've done that part. And once we've done that, then we can plug that in to find our x, the actual measure of angle R, which was 5x plus 2. So we're going to do 5 times 9 plus 2. So 45 plus 2, 47 degrees. All right, what kind of questions do you have on that one so far?
What is this?
We're using the exterior angle sum theorem. Okay, I'm going to give you a minute to try number 4 on your own. So if you're watching the video, just pause the video and go ahead and try to solve number 4. Okay, so for this one, we would set it up angle D, which is 39 degrees, plus angle C, which is 8x plus 17, equals, and then you've got that outside exterior angle, 15x minus 7. And you should have ended up with x equals 9, right?
Yes.
So we get x equals 9, and they wanted the measure of angle RED, which is this one here. So we would do 15x minus 7, so 15 times 9 minus 7. And what did you get? 128. Okay. So that's the exterior angle theorem. Yes.
When you write the answer, would I write like angle RED equals 128, or like the measure of angle RED?
You would say the measure of angle RED equals, if you were formally writing it,
Okay.
that's what you would write.
If you
Yes.
just wrote the angle of RED equals, would that still be correct or no?
No, if you're going to put the angle and you're going to say equals, you need to put the m in front of it. And that's the correct way. It depends from teacher to teacher who's going to count things right and wrong, but that's the correct way to write it.
What was the answer number 3?
It was, the final answer was 47. X was equal to 9.
Thank you.
Okay, if we come back up here to the top, we've talked about the first 2. And now I want to talk about the interior angle sum theorem. So I'm actually going to come over here, and I want us to all draw some shapes. Draw a quadrilateral, and I'm going to draw one that is not like any of the shapes that we're familiar with. So here's my, just out to the side. It doesn't need to be super big, but just draw a quadrilateral, so it needs to have 4 straight sides. And then once you have it, I want you to choose one of the vertices. I'm going to choose this one. You can choose whatever you want. And then I want you to draw a line that connects your vertex to all of the other vertices on the shape. Now some of those lines are already going to be there, right? But this is what we get. So how many sides did our shape have? 4. And how many triangles did it make? 2. So no matter what kind of a quadrilateral you guys drew, when you drew these lines, everybody ended up with exactly 2. And if you look at all of the angles, everybody watch while I do this. The angles of this triangle are these, right? And the angle of my top triangle are those. And if we add all of those together, I get this one, this one, this one, and this one. So those are all of the angles of the quadrilateral, right? Mm-hmm. So if this triangle had 180 degrees when we added up all of its angles, and this one had 180 degrees when we added up all of its angles, then what should the whole shape have? 360. This is the point of this exercise right now is really just to look for a pattern. We're not going to go through this whole process every time we want to know what's happening. So the next shape we're going to draw is a pentagon. And if you can draw a regular pentagon, great. If you can't, you can do what I'm going to do, which is draw a house. My basic 4-year-old drawing of a house that looks like this.
Oh.
Right? It has a little equilateral roof, and it has a square for its base. Who am I kidding? My houses still look like this if I draw them. And you're going to do the same exercise. You're going to select one vertex, and you're going to connect that one to all of the others. Everything is triangles. So we started out with a shape that had 4 sides, and how many triangles did it make? 3.
Wait, 4 sides?
5 sides? So a 4-sided figure gave us 2 triangles. A 5-sided figure gave us 3 triangles. Guess what a 6-sided figure would give us? 4.
So
What's the relationship there?
side
Even
minus
not.
2.
The number of the sides minus 2 tells you how many triangles. And how much is each triangle worth? How many degrees? 180. So this would have an angle sum. All of those interior angles would add up to 540 degrees. So that's where this formula that's at the top of your page comes from. It says S, that's the sum of all of the interior angles, all of the inside angles of the polygon is equal to the number of sides the polygon has minus 2, because that tells us how many triangles it would make, and then times 180, because that's how many degrees are in each one of our triangles. Yes?
So do the first 2 only work for triangles, and then the next one only works for not triangles?
It also does work for triangles. It just seems silly to do it for a triangle, but yes. Yeah, the first 2 only work for triangles. And then this one we really use for everything else. Okay, so let's look down here in our examples. This first shape, we need to know how many sides it has. So I like to put tick marks so I can count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to write 9 sides in the middle. So our shape has 9 sides. So if we want to find the sum of all those interior angles, we're going to do n minus 2, and n was 9, so 9 minus 2. And multiply that times 180. So 7 times 180. Has anyone calculated that? 1,260 degrees. The instructions on this, well, let's go back to the instructions. Said find the measure of one interior angle. So we actually found all of them added together, right? But this says in each regular, highlight this phrase, regular polygon. Does anybody remember what a regular shape is?
Just the one that's like all the things are equal, you know.
Yes, all the things.
Like a square.
So all of the angles are equal. It's equiangular. All of the sides are the same. It's equilateral.
That's equiangular
Yes.
does not roll off the tongue like it should.
Right. So since this is a regular 9gon, all 9 of those,
It's a
nonagon. All of those angles would be congruent. So if it's 1260 for all of them,
Divided by 9.
yes, we would just do 1260 divided by 9
140.
equals
140.
140 degrees. Now, before we move on to the next shape, I want to talk about the exterior angles of this nonagon. So I'm going to extend, this is not part of this problem, this is just an example. I'm going to extend this side, and I want us to talk about just this angle right here. So we just found that all of the interior angles are 140. So this angle is 140. And we can see that each interior angle with its exterior angle forms a line, so they're a linear pair, which means they're supplementary. So if the inside one is 140, what's the outside one? 40. How many of those 40-degree angles are there for this shape? 9. So what's 9 times 40?
Let me do it.
1260.
360.
360, like, can I drop into a 360?
So, no,
So all you have to do
360
is
degrees.
divide the
So-
amount of sides by 360 to get the number
If
of
we
the
want it.
exterior angle.
We know how many exterior angles there are. But if we wanted to know what they were,
Yeah.
yes. Yes.
Recording?
So,
Oh.
yes. So up here, you'll notice, up here at the top, it said, the exterior angle sum theorem is that the sum is 360 degrees. No matter what the polygon is, if you add up all of the exterior angles, it's always going to be 360 degrees. It's true for a triangle, it's true for a square, it's true for a kite, a pentagon, a hexagon, an octagon, all of them. The exterior angle sum will always be 360 degrees. Okay, so coming back, we had a pentagon. So it has 5 sides. So if we want to know the angle sum, we would do 5 sides minus 2. Tells us it would make 3 triangles. 3 times 180 is
540 and then divided by 5.
okay, so 540 degrees is the total interior angle sum. And then we want to know what each one is. So we divide by 5. And you got
Oh,
108 degrees. So each of these angles inside is 108 degrees.
I have a question.
Yes.
If we don't have online school tomorrow, are they just not going to do this?
Okay, so each angle would be 108 degrees.
Ow!
Okay.
Sorry.
So last piece here is on the exterior angles. And we said that the sum of the exterior angles is always going to be 360 degrees. And it says find the measure of one exterior in each regular polygon. So since they're regular, we know all of the angles are the same.
Wait, why would it be 360?
That's the rule.
Oh, that's where, okay, I got it.
So this first figure, if you count up all the sides, has 11 sides. So if we want to know what each one, let's just draw one exterior angle. Go ahead and draw this so you can kind of see. That's what you're calculating for. And you can see that it's a small angle, right? So we should be getting a small number when we do this. So we're going to do 360 divided by 11. And it says to round to the nearest tenth if necessary. So if we don't have to round, we don't worry about it. But go ahead and do 360 divided by 11.
32.72 repeating.
So
73.
So one more time.
32.73.
32 point. It's at 10, so 32.7.
Oh, okay. Oh wait, this isn't. Oh wait.
And then the last one, what shape is that?
It's a
square,
I was
right? It's a
about to
square.
say triangle, but
And so we know since the inside is 90 degrees, the outside is
90.
90 degrees. I wouldn't expect you to have to show work on one like that. So your assignment then is this interior and exterior angle page. It is two-sided. Read the directions carefully. Like on the first, it just says find the angle sum. So you're just finding the interior angle sum. You're not finding each angle. But on the second section, it does say find each angle. So then you would change that. When you get to 15 through 20, if you look at those, it just says solve for x. So you're not finding a specific angle measure. You're just setting up an equation, solving for x, and that's all. So the answer key is on the backboard here in the classroom. Online, it's down here at the bottom of this page. So this is in the content library under the geometry tab. It's the bottom one. So if you need the answer key, it's there. Be sure you show all of the steps that you did. I know a lot of this is on the calculator, but write down what you're plugging into the calculator so we can see what you did. Okay, that's it.